Dear students, next topic is equation of progressive wave. In this topic, we will study how the equation generated. We were earlier studied that we have used this equation y is equal to xt is equal to r sine 2 pi by lambda vt minus x, which was a great question ki how does this equation come. So in this topic we will study. Okay, so equation of progressive wave. Suppose we are having this wave. At this, the wave is traveling like this, such that the this is the direction of propagation of a wave. This is the wavelength of a wave. Okay, so let us consider at any instant of time at point P, the particle is at point P, which is at a distance x from the origin. Okay, so in time t, suppose small time t, it reaches at this point. Suppose at this point. So this distance will be vt. Okay. So we can write that this distance is vt minus x. I think this is clear. Where v is the speed with which the plane progressive wave is moving. O is at origin. Okay. So clearly we can say that here the particle which is at O and the particle which is at position P will be facing certain angle, phase angle. We have studied in previous chapter. Suppose a particle is at this position, mean position, and another is at any position at this point P, making an angle, suppose theta, okay, or phi. So in that case we have derived the equation y is equal to a sine omega t minus phi naught. Okay, so clearly if the particle is at position O, in that case the y equation is given by r sine omega t. We have already studied in our previous chapter. So now since it is facing a particle P at P is facing some phase lag of suppose phi, then the particle at O, then the equation at that point can be written as r sine omega t minus phi. Okay, now since for a distance of 2 pi, for a distance of lambda wave, the phase changes by 2 pi. We have also studied that lambda wave means for the full circle length or for the full oscillation, the total angle traversed is 2 pi, which is 360 degree. So for one wavelength it will be 2 pi by lambda, and for the x distance of wavelength it will be phi, which is 2 pi by lambda into x. Okay, so writing this value here, y is equal to r sine of omega t minus, this is 2 pi by lambda into x. Now putting omega is equal to 2 pi by t, r sine of 2 pi by t into t minus 2 pi by lambda into x. So taking 2 pi common, we will be having r sine of 2 pi taken out. This is t by capital T minus x by lambda. So this is the equation of plane progressive wave, and we can write in simple form also. We know that v is equal to nu lambda. Okay, v is equal to nu lambda. Basically, so we are having nu is equal to 1 by t, so v is equal to lambda by t, which is distance upon time. So v is equal to nu lambda, or from here frequency nu can be written as v by lambda. Okay, and frequency can be written as 1 by t. So 1 by t is equal to v by lambda. So putting this value here, we will be having, this is r sine of 2 pi. Instead of 1 by t, we will put v by lambda into t minus x by lambda. So again taking lambda outside, r sine of 2 pi by lambda taken out, vt minus x. So this was the equation of plane progressive wave that I told you earlier, and this is how it originates. Okay, so in this case the particle is moving in a positive x direction. Suppose the particle is moving in negative x direction, in that case the equation will become y is equal to r sine 2 pi by lambda. This is vt plus x. So sometimes the equation will be used vt plus x. In this case the particle is moving in negative x direction, and vt minus x if the particle is moving along the positive x direction. So this is the equation of plane progressive wave. Now there are certain terms that phase changes with time. Okay, so phase change with the time can be represented as delta phi is equal to 2 pi by lambda, 2 pi by t into delta t from this expression. 2 pi by t into delta t. Okay, and with position we can write delta phi is equal to 2 pi by lambda with negative sign delta x. This is 2 pi by lambda delta x. Okay, now for example, the particle is at a distance of lambda by 2. Lambda by 2. So in that case, delta phi can be measured as 2 pi by lambda into lambda by 2. So that is equal to pi. So clearly when the particle is having, is at the position this, at the distance of lambda by 2, the phase change is pi. When it is at the lambda length, it is 2 pi. So putting lambda here, delta phi is equal to 2 pi by lambda into lambda. Okay, so this is 2 pi. So for a wavelength, the phase changes by 2 pi. For a half wavelength, the phase changes by pi.